my name is Connor Blakely, and me and Peter Truong recently took a robotics course at Siena College. Our project was vampire survival, so in a sense our robot would run away from light. During our presentation, our robot would look in 7 preset directions using our Xbox Kinect, and at each direction it would take the image, get the pixels from that image, average them out, and get that value. So after 7 directions we would get 7 values. We would then find the lowest value, which meant the darkest area, and we would go in that direction. Here's our demo.
The basis for this project was to create a robot who was afraid of the dark, sort of like a vampire.
In order to run our project, we need to launch our launch file, which is found in our Project Mayhem package. Our launch file consists of 3 nodes, which are Turning Wheels of Death, Light Analysis, and 360 Check node.
In our first demo, the room is lit up in order to demonstrate the robot's movements. Ideally, we wanted the cape in order to represent Dracula, and also hide the brightness of the laptop screen. But this would later conflict with the robot's tuning. However, in this demo, our robot does just fine because it's only moving forward.
Our test room is lit up with lamps we use to change their environment for different trials. The robot, after starting, looks in the 7 preset directions and grabs the pixels needed. At each pause, the average of those pixels is being taken and the value is stored. As said before, after the 7 directional values are stored, the robot finds the lowest value and tells Turning Wheels of Death node which direction to take.
To go more in depth, 360 check node sends each brightness value from each direction to light analysis node, where light analysis node determines the lowest value out of those 7. Then light analysis sends the direction to Turning Wheels of Death node. Once the value has been received by the Turning Wheels of Death node, it will turn the base of the robot in the corresponding direction. After it is done turning the base, the robot will proceed forward in the direction of the lowest light.
We ran into 2 major issues while working on our project. First was the way the Kinect took an image. Instead of a picture, it took a constant stream, but with some troubleshooting and logic we figured it out. The second issue was light. As you may notice, the glare in our test room is not ideal, but we contained it enough to have a successful project. As seen from our last 4 demonstrations, after the robot determines the direction with the least amount of light, it successfully moves away from the light sources with an outstanding amount of accuracy.